Green and Zerner is a book about elasticity, but essentially it's a book about continuum mechanics with a special reference to elasticity. Continuum mechanics includes fluid mechanics, elasticity, plasticity, and so on. And the central thing about all these disciplines is the ability to talk about, firstly, whereabouts you are in space, and secondly, about forces which you can resolve into certain directions, and strains and stresses. And the main difference between, say, fluid mechanics and solid mechanics, which includes shell theory, is that in fluid mechanics, you normally have the fluid flowing past your coordinate system, whereas in solid mechanics, if you're sensible, what you do is you have your coordinate system moving with the solid. So that's why I've got this sponge here. And you can see that I've drawn on the sponge a coordinate system. I can move the sponge around, and that's fine. The coordinate system moves with it. From the point of view of the sponge, it takes the coordinate system with it, if you like. And if you had a system of, say, X and Y axes that were fixed in space, they would be, to a large extent, irrelevant. And the same applies to your own body as you move around. You take your coordinate system with you. But of course, also, when the structure is deformed, then the coordinate system is deformed with it. And even if you drew a system of coordinates like this, which consisted of straight lines crossing at right angles, then after you've deformed it, then you no longer have straight lines, and the lines don't cross at right angles. Now, of course, because this sponge is a three-dimensional object, in fact, what you don't have is a series of lines. You have a series of planes. So you could start off, because this sponge is fairly rectangular, you could start off with a whole pile of planes parallel to this direction, cutting it like that, a series of planes cutting it like that, and then a series of planes cutting it like that. So that would be like a Cartesian coordinate system. But then, as I said, once you deform it, then those system of planes become curved surfaces. And so what you have to be able to do is to use those curved surfaces to help you understand what's happening with this material. Of course, what happens is that you don't actually have a real system of coordinates, but you imagine that there was a system of coordinates like that.